Hi, I'm Dr. Jason J. Campbell, and I want to thank you for taking the time to watch my videos. In this video, I'm going to present a series of logical problems that I'm just presenting to my community of viewers for you guys to discuss amongst yourselves. I'm suggesting that you guys leave comments on what you think some of the solutions to these problems are. I'm not going to participate unless you ask me directly in the comments. But I'd be interested to see what you guys have to say. A lot of you have very advanced understanding of logic, and I thought it would be a good assignment to give my viewers. So if you're interested in a little bit of logical fun, try discussing some of these solutions or potential solutions to the problems that I'm going to pose, and hopefully you find it moderately entertaining. Okay, so with that, let's begin. This will be problems in logic. So the first problem that I want to pose, and I'm not going to explain it at all, I'm just going to put it up here. If you've been watching my videos, you should have an understanding of all of the sort of the syntax. You should understand what this means, and try and answer it. Try and figure out, can I make sense of this? So if you have this claim, right? If you have this claim, and we'll call this, let's call this that sign. The question is it true that it's equal to this? And we'll call that that sign, right? And the question is it true or is it false, right? Is this true or is this false with respect to these two? Pretty technical question. If you say that it's true, then does its Venn look like this, right? I'm going to give you options, right? This is option 1A, and the option is this. So that's option 1A. Next option, 1B. Does it look like this? Does it look like that? 1C. I'm going to make this a little bigger. Does it look like this? Does it look like that? 1D. Does it look like this? Or 1E. Does it look like this? Okay, so this is the first problem, right? I'm not going to explain anything more than that. It would be interesting to see what you guys have to say about this, right? Given this, is it true or false that this is the case, right? Given this state of affairs, which we'll symbolize as an instantiation, an existential instantiation, is this the same as P, right? Are these the same? If you say it is the same, if you say it is true, then how would we symbolize it? If you say it's false, how would we symbolize it? And also, if I've missed some possible Venn representation, what Venn representation have I missed? It'd just be interesting to hear what you guys have to say about this, right? So this video is not really a video of me doing any lecturing. I'm sort of interested in going through and reading your comments on problem number 1. So this is problem number 1. And I'll wait to see your comments. Problem number 2. Tell me what... Tell me a little bit about this problem. Tell me what you think about problem number 2. I'd be interested to read your comments and see what you have to say about problem number 2. What does that mean? Why did I choose that? Right? Tell me a little bit about problem number 2. What you think about problem number 2. Again, I'm interested in hearing what my subscribers and viewers have to say about this logical problem, right? So that's problem number 2. Problem number 3. Problem number 3, I'm going to draw a series of Venns, and I would like to see what the community of viewers have to say about how these Venns would be worded. How would you word these Venns? What do these Venns represent, right? So 3.1 is represented by this. So that's 3.1. What does that mean? 3.2 is represented by this. .2 is represented by that. Okay. 3.3. Okay. 3.3 is represented by that. Okay, so what does this mean? What does this mean? What does this mean? 3.4. 3.4 is this. .4 is represented by this. Okay, what does that mean in 3.4? Let me shade this one in a little bit more. Okay, and then 3.5. 3.5 is this. And just to be consistent, let me put this down here. Alright, so what does this mean? 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 Right? These are just problems that I decided to cook up for my viewers. It'd be interesting to see what you guys have to say about what the answers to some of these questions might be. Alright, and then lastly, number 4. And actually, I'll probably write number 4 over here. Number 4. Okay, you know that you can draw a cube like this, right? So we draw a cube, right? We draw a cube, and we draw a cube. At each point, we're going to give it a letter. So there's a point here, there's a point here, there's a point here, there's a point here. 1, 2, 3, 4, 5, 6, 7, 8. So we draw our cube, right? Now we're going to label each point, right? This is going to be point label A, point B, point C, point D, point E, point F, point G, and point H. Okay? So we have our cube, and each point has a letter. And I have some questions, right? So question 4A is the following. What are the total number of ways, this figure can, right? What are the total number of ways this figure can be drawn? So just to make sense of what I mean by this. You could say that to draw this picture, you would go from, like how I really drew it, right? The way that I really drew it was, I went from point A to point C, then from point A to point G, then from G to point, then from G to E, then from C to E, then from B to D, then from B to H, and so on and so on. I drew it that way. But somebody might say, well, no, the first thing that I'm going to draw is from H to G. And then I'm going to draw B to D, and then C to D, and blah, 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 blah. So there's not an infinite number of ways, there's many number of ways. The question that I'm asking is, what are the total number of ways this figure can be drawn? Right? Keep in mind that if I say I go from A to G, and then from G to E, it's not the same, though the shape is the same, as saying I go from E to G, and then from G to A, or from G to E, and then G to A. So what are the total number of ways that this figure can be drawn? That's question 4A. Question 4B is Okay. What are the most amount of strokes needed to get from point H to point D? From point H to from point H to point D without redrawing a stroke. What are the most amount of strokes needed to get from point H to point D, without redrawing a stroke? So for example, you could say, oh, well, I could go from H to G, which would be 1, and then from G to A, and then from A to B, and then from B to D. Sure, that would be fine. But you couldn't say, like, from H to G, from G to H, right? You've redrawn that stroke. So, sorry. Alright, so let me mute this. So the question is, what are the most amount of strokes needed to get from point H to point D without redrawing any strokes? What are the most amount of strokes needed to get from point A to point D without redrawing any strokes? Leave your comments. All of these, you know, and this is for you. This is not necessarily for me, but I'm interested. Leave your comments so that I can see, you know, what you guys think about, you know, these questions. Pick a question. If you don't have to answer all of them. You don't have to answer any of them. But this is for the community. Last question, 4B, or 4C rather. 4C. Okay. What is the average, and I mean statistical average, what is the average number of strokes needed to get from H to D? From H to D. Okay, so these are the questions. Let me go over the questions once more. If you want to answer all of the questions, feel free. Leave comments and answer all of the questions. I'd be very, very interested. I want to know what you guys think about this, right? I'm not going to give answers to this. Some of these, you know, might not have an answer. Some of these do have answers. It'll be interesting to see. I just want to see what you guys think. First question, is this claim, which will represent as existential instantiation, and this claim, which will represent as P, we know that that means possible if you guys have been watching my videos. Is this claim true or false? If it's true, which one of these represents its truth? If it's false, which one of these represents its falsity? Also, if I've forgotten some form of sort of diagramming it using Venns, what have I forgotten? Okay, next, tell me what this means, and you know, what's interesting about this claim, number 2. Why is that interesting? Or is it interesting? Number 3, a different series of overlapping A's and B's. What does this mean? What does this mean? How would you say this? Or you can get really nerdy and symbolize it, right, if you want. What does that mean? What does this mean? What does 3.3 mean? What does 3.4 mean? And what does 3.5 mean? What do these mean? Number 4 is, given this cube, what are the total number of ways this figure can be drawn? In its totality, right? From A to C, from H to G, from B to D, from D to B, and so on, right? What are the total number of ways that this can be drawn? Number 4, what are the most amount of strokes, right? What are the most amount of strokes needed to get from point H to point D without redrawing a stroke? What is the highest amount of strokes needed to get from point H to point D without redrawing any strokes? And lastly, numbers 4C, what is the average number of strokes needed to get from point H to point D? Right? What is the average, statistical average? What is the average number of strokes needed to get from point H to point D? So that concludes this video. Hopefully you enjoyed my last video, my tour of the office. This video is something for you guys to chew on, a little bit of logical little bit of logical fat to discuss amongst yourselves. And I'm going to sit back and just see what comments you guys have to say. I'm not really going to participate in the comments unless you want me to, but I'm more interested in seeing what you have to say about answering some of these problems. With that being said, I want to thank you for taking the time to watch my videos. I'm Dr. Jason J. Campbell. Thanks, and have a good day.